In this video, we're going to be using the theorems that you see on the screen here to solve some problems. Now, I don't want you to worry too much about trying to memorize the name of these theorems. We just need to be able to apply these theorems to determine if lines are perpendicular to each other or parallel to each other. And so these theorems are found on page 83 and 84 of your journal. We have the linear pair perpendicular theorem that we might need to use. We have the perpendicular transversal theorem and the lines perpendicular to a transversal theorem. And so we can use these to determine if lines are parallel or perpendicular to each other. And we're going to practice this on page 85 in your journal. For extra practice, we're going to do 5 through 8 in this video. So go ahead and make sure you are turned to page 85 in your journal. And in 5 through 8, our job is to determine if any lines in the picture are parallel based on the given information. Okay. We've done problems similar to this when we were talking about our special angle pairs. And so looking in this picture in number 5, I can see that there is a right angle here, which means line P is perpendicular to line S. So that's something I do know. Remember, this is the symbol for perpendicular. So obviously, line P and S can't be parallel because they're perpendicular. So now, if I'm looking, I'm wondering, maybe P and Q are parallel. They kind of look parallel. However, can I conclude that they are? And notice, I do not know anything about any of the angles that are on line Q here. So unfortunately, I can't use any of these angles with this right angle to determine if P is parallel to Q. So I actually don't have enough information because I don't have any information about any of the angles on line Q. So I'm just going to say no, there is no info about the angles on line Q. Let's move on to number 6. So in number 6, I can see that I've got a couple right angles in the picture. Okay. This tells me that line P is perpendicular to line R and line Q is perpendicular to line R. Now you can think about this problem in different ways, but what we learned is that if two lines are perpendicular to the same line, then the lines must be parallel. So by looking at these two right angles, we know line P is parallel to line Q because both lines are perpendicular to line R. Right. This fancy name for this theorem is, and remember, this isn't super important to remember, but the name of this theorem is the line perpendicular to transversal theorem. Okay. Another way to think about this, we also know P is parallel to Q because if you look at these two angles, these are corresponding angles. And if they're both right angles, you know they're congruent. And so we know by the corresponding angles converse that if corresponding angles are congruent, then your lines must be parallel. So you could think of this using both theorems. Either way is fine. All right, and number 7, I want to determine if there's any parallel lines. So first, let's go ahead and let's look at M and N. Let's see if we can figure out if M is parallel to N. So I'm interested in a transversal that cuts through M and N. that I know some information about the angles on it. If I look at this transversal K, I notice K is perpendicular to both lines M and N. Okay. So since both M and N are perpendicular to line K, this tells me that M has to be parallel to N because both lines are perpendicular to K, are perpendicular to line K. That would be the same theorem as up above. The line perpendicular to transversal theorem would be the proper name for that theorem. Well, let's go ahead and let's look at J and K. So lines J and K. Let's see if they might be parallel. So we're wondering, is there a line that I see that they're both perpendicular to? And I can see that J and K are both perpendicular to line M. So since they're both perpendicular to the same line, I know J has to be parallel to K. Both lines are perpendicular to line M. That would be another line perpendicular to transversal theorem. Finally, we're moving on to number 8. First thing I see, I notice here that I've got some extra information. I've got angle 1 and angle 2 here, that they're telling me they are a linear pair, right? They make a straight line. And I also know that they're congruent. Well, by the linear pair theorem, the linear pair perpendicular theorem, we know if 1 and 2 are congruent and they make a straight line, they both have to be 90 degrees. That's the only way they can add up to 180 and be congruent. And so we know that these are right angles here. So I'm just going to say, I'm just going to add in my picture that these are right angles. Okay, that's not very good. The measure of angle 1 and the measure of angle 2 equal 90 degrees. I'll just add that in there. So these are 90 degrees. So this might help us now determine if any of the lines are parallel to each other. So let's go ahead and let's look at line M and N first. So I'm wondering, are line M and N, are they perpendicular to the same line? And I'm looking here and I can see that line M is perpendicular to line S, and from what I just discovered, line N is also perpendicular to line S. So this tells me that M is parallel to N because they are both perpendicular to line S. Let's check line S and T. I'm wondering, are they perpendicular to the same line? Notice line S is perpendicular to line N, and line T is perpendicular to line N. They are both perpendicular to line N, which forces them to be parallel. So S is also parallel to T because they are both perpendicular to line N.